This topic is really about combining topics. What we have here is a ballistic pendulum. So a block, it's hanging from two strings, and it's free to move. It can swing this way, that way. Initially, it's at rest, but a bullet, okay, mass one, velocity v1, is fired at the pendulum, and there's going to be a collision here. The bullet is going to get embedded into the block. Together, they will move with a new velocity v2, and then the pendulum is going to swing upward, and its height will change. And what we should do is figure out what topics do we use to solve this. What models do we use to figure out the velocity to and the height change. So anytime you have a collision, so here the bullet and the block, you should think momentum, the conservation of momentum. So that's what we're going to use to solve the first part to figure out v2. And a lot of times when something changes heights, you should consider the conservation of mechanical energy. There we go. And that's what we're going to use to solve this. So I'm going to move this down here so I can get some room. So the two objects are separate, and here they're going to combine. So it's going to be like a hidden stick collision. So we'll say m1 v1I. I'm just going to write this equation that we have memorized from class. And I'll use v final here. But once I start putting in some numbers, or really what I'm going to do is put in some symbols, I want to use the values that the problem gives us, the notation that the problem gives us. So mass 1 is still mass 1, and v1I is just v1. So I'm looking here. And okay, this one is not moving. The block is not moving, so I'm just going to cross it out. Equals mass 1 plus mass 2. And they're calling v final v2 in the problem. So that's what I'll do here, just to change up the notations. Then we'll put in some numbers. 0.04. v1 is 240 to the right. And mass 1 is 0.04, whoops, plus 2.96 times v2. Okay, this is 9.6 equals 3v2. And so 9.6 over 3 equals v2. And that is 3.2 meters per second to the right. On the AP test, it will typically ask you in a separate question, what's the direction, but I think in this case, it's pretty obvious. So that's v2. Okay, so now the instant that the bullet is embedded in there, they're not moving with velocity v2, and it's going to start swinging upward. And this was part A. Okay, part B, this turns into a conservation of mechanical energy problem. And so just to be consistent with the v2 here, I'll call this 2 and I'll call this 3. And I'll say E2 equals E3. Okay, K2 plus UG2 equals K3 plus UG3. And I didn't write this very well in the notes, but the pendulum essentially moves up until its speed is 0. So it's just its maximum height. That's what h is. So up here it's going to have zero speed. Excuse me. Because at 2 it's like at the lowest point. I'm going to cross out UG. We'll make that 0 height. And then we just have K2 equals UG3. Well, the kinetic energy at 2 is just m1 plus m2 times v2 squared over 2. And at 3, the gravitational potential energy is M1 plus M2 GH. We can cancel the mass 1 plus mass 2. And we're solving for height, so this would be V2 squared over 2. I'm going to divide both sides by G to get H by itself. And now I'll put in some numbers. That was 3.2 squared over 2 times 10 equals H. And we get that the height is 0.512 meters. So that's kind of our strategy, is figure out what, what topics do I use to solve things. Let's go to the next one. Okay, we have a table. There's a block on the table that's not moving. A bullet is moving with speed v naught. The mass of the bullet is m. The mass of the block is 8m. There's no friction, and the table is height h. Okay, the bullet is going to go and collide with the block, but notice that the bullet does not get embedded. It goes through the block. On the other end, the bullet is moving with 1/3 of v naught, and we need to figure out what is v2, the velocity or speed of the block. So that's part A. And then part B is, the block is sliding here on the frictionless surface with that same speed v2, and then it's going to fall down to the ground. We want to figure out what is the horizontal distance from the base of the table to where it lands. And so, again, collisions, this is conservation of momentum. And then this part over here is kinematics, particularly projectiles. Okay. And numberless problem. Let's start with the conservation of momentum. So we'll say m1 plus m1 v1i plus m2 v2i equals m1 v1f plus m2 v2f. Because the block is labeled v2, I'll make the block mass 2. And so let's replace our variables here with the notation in the problem. So the bullet is mass 1, but it's just m. The initial velocity of the bullet is v naught. I'm just going to take this out. The block is not moving, so equals. Okay, mass 1 is just m, but it is now moving with speed v naught over 3, or velocity, I should say, is v naught over 3 plus the mass of the block, 8m, and we're going to figure out v2. Okay, so m v naught equals, I'm just going to say this is m v naught over 3. Didn't really need to break that into a separate step there. We can cancel m's. And I want to isolate v2. So I'm going to subtract a v naught over 3 to both sides. So this will be v naught minus v naught over 3 equals 8v2. Okay. Well, let's get a common denominator here. So v naught is the same thing as 3 v naught over 3. And now we can subtract them. So 3 v naught minus v naught is 2 v naught over the denominator 3 equals 8v2. Okay, and then once we isolate v2, we get v2 equals v naught over 12. So if you divide both sides by 2, this is just v naught over 3 equals 4 v2, and you divide by 4, you'll get the 12. So that was part A. Part B is a projectiles problem. Okay. That's 0. Vx, the horizontal velocity of the block, is whatever v2 was. That's v naught over 12. Kind of trying to squeeze that in there. The initial height is height h. The final height is 0. The initial vertical velocity is 0. And a is negative g. Since this is numberless, we'll use negative g instead of negative 10. All right, the equations that we use for this sort of problem is y equals y naught plus vy naught t plus 1 half at squared. So let's start substituting. This is h. Vy naught t is 0. And then it's just plus 1 half negative g t squared. How do I want to do this? Since we're trying to isolate t, we can move over the h, get a negative h. And this will be negative g over 2 times t squared, just rewriting that. We can drop the negatives here. We're going to multiply, so we'll drop the negatives real quick. We'll multiply both sides by 2, and we'll divide both sides by g. So this would be 2h over g is t squared. And then we'll just square root it. So square root 2h over g equals t. But that's not our answer. We want to figure out the horizontal distance. From the base of the table. So x, make that 0. Vx, which is just vt, v2, excuse me, is v naught over 12. And t is the square root of 2h over g. Didn't need the parentheses there, that's fine. All right, and let's do the last one. Okay, bullet block, M1, M2, bullet, the velocity is V1. It's going to collide with and embed itself into the block. Together they move with a new velocity V2. So of course that's just momentum, conservation of momentum. Now this is a rough surface, so now the block will move from this point to this point across a distance d and end up with 0 velocity. What do we want to know? We want to know what is the speed of the bullet block and how far does the block slide. And so, okay, to figure out this part, this is interesting. You can actually use, because we know mu, yeah, you can actually use forces and then kinematics. You can use, because there's mechanical energy here and then 0 mechanical energy here, mechanical energy is not conserved because friction is doing work on the system. So we could use energy and non-conservative forces. But the way I'm going to do it in the video is the work kinetic energy theorem. Which is essentially the same as the energy non-conservative path. Okay, so let's do part A. This is M1 V1I plus M2 V2I equals this. Cool. I think we can just put in numbers. Let's cross this out. The block is at rest. So we'll say, whoops, M1 is 0.06, V1 is 300, equals 0.06 plus 3, it's a weird 3, 0.94. Let's use their notation, V2. So sorry about the noise if you can hear that. And so this becomes 4V2. This is 18. And so V2 is 4.5. Of course, it's moving to the right. Okay. Work kinetic energy theorem. The network is equal to K final minus K initial. The final kinetic energy will be 0. So the network is just equal to negative Ki. Well, what is the network? Well, if we drew a free body diagram, which I guess I could do, there's mg, there's Fn, and since the thing is sliding this way, d, there's a friction force there. And so the only work being done is by friction, and so that is the network. So W net is equal to the friction force. Well, or the network is the work done by friction. So they're in opposite directions. We're going to use negative friction force times distance equals negative K initial. And we don't know the friction force, but we know that it's mu K. We'll use mu since they don't have mu K here, it's just mu. Mu K Fn. So I'll write that for a moment. D equals negative Ki. Oh, we can drop the negatives. Divide both sides by -1 or multiply. And we'll say mu times mg d equals, let's back it up a little bit. Made this mistake in class too. It's the bullet block. So it's m1 plus m2 g d equals the initial kinetic energy, which is m1 plus m2. The initial kinetic energy is when it's moving at v2 over 2. We can cancel the masses. And if I were to isolate distance, which is what we're trying to solve for, how far, then it will be v2 squared over 2 mu g. And so the distance is 4.5 squared over 2.610. And our calculator gives 1.69 meters. I challenge you to try forces and kinematics, see what you come up with. you will start with forces first because you need the acceleration, and then determine the distance that way.